Welcome back. All right, so in this video, we are going to give an example for deriving demand function. Now, in the last video, we actually went ahead and derived the demand function for Rory, and we went through the whole process. We talked about what these numbers mean. So a quick review, Rory's utility function is this. We actually use this version. We said this is her budget constraint. We also talked about the optimality condition. And we used all of that information, where that's the optimal point, to find Rory's demand function for good X and good Y. It ended up being these two values here. So now let's go ahead and actually plug in some numbers to see if how that works. I'm actually going to do the graphical derivation in a different video. So in this video, we're going to do a numerical example. In other words, an example, let's write this out this way. Example using specific numbers for income, Q of X and P of Y. Remember when we solved this the first time, we said that this is Rory's demand function for any value of income for her income. So it could be 1,000, it can be 1, it can be 2 billion if Rory's got it like that, right? Whatever number, we can plug that in and we'll find her optimal. We know the function for any number. Now, we can actually go through this and find Rory's demand function for specific numbers. So let's get that information. So now let's suppose that the income that Rory has is $100, right, for this budget. The price of good X is $5. Remember, good X can be anything. It can be ice cream, shoelaces, but we're just calling it X here to be general. And good Y here is equal to 2. Remember that Rory's utility function as QX and QY is equal to QX raised to the power of 0.5 times QY raised to the power of 0.5. Now, from the last video, using this information here, we found that Rory's MRS is equal to negative QY over QX. Remember, where we need that optimality, we need that optimality condition. MRS is equal to MRT, so that we can derive that demand function. Okay, what else do we know? We also know that MRT is equal to negative P of X over P of Y. Right? MRS is the slope of the indifference curve. MRT is the slope of the budget constraint. This optimality condition is the point where these two curves are tangents to one another. This is Q of Y, Q of X. Okay, optimal point of optimality. We talked about all of this in the last video. That was a quick reminder here. All right, so let's use these specific numbers and find Rory's demand function, right? That's what we're trying to derive. We need this to, let's just stop there and move on. So, using these two pieces of information, we have the negative Q of Y is equal, well, and this, over Q of X is equal to negative P of X over P of Y. We can solve for Q of Y since it's in the numerator up here. So Q of y is equal to negative P of x over P of y. Actually, the negative sign can come off, right? Because these two can cross out. So let's just do that. Times Q of x. Well, remember, we have numbers for these things now. So Q of y is equal to, what is P of x? 5. P of y is 2. So 5 over 2 times Q of x. This is not the end though, right? Because Rory only has $100 to spend. So we need to plug this into Rory's budget constraint. And that budget constraint is I is equal to P of x times Q of x plus P of y times Q of y. Now remember again, we have numbers, so this would be equal to 100 will be 100 is equal to P of x is 5, so 5 Q of x plus 2 Q of y, right? In some other places, you might have seen this as 100 is equal to 5x plus 2y, right? But just so we're consistent and we know that we're talking about the quantity of x and the quantity of y, in this example and this analysis, these videos, we're going to be using Q of x here and Q of y. Okay. So with this information, we can plug Q of y here. So we have that 100 is equal to 5 Q of x plus 2, 5 over 2 Q of x. These two can cross out, right? So we have 2 times 5 divided by 2 is 2 over 1. So they can cross out and we're left with just 5. Okay. So we have 100 is equal to 5 Q of x plus Q of x. Then 100 will be equal to, have I dropped something, class? Anything different? Any comments? Oh, that's right. What happened to the 5, Professor Amy? Well, it was dropped and it shouldn't be, so let's fix that. That's the nice thing about math though, you can always find your way back. Alright, so 100 is equal to 10 Q of x, right? Because they're both Q of x. How did I know to stop? I realized that 6 was not going to divide 100 nicely. So I had to look back and see if that was actually what I wanted. Anyway, so we have Q of x is going to be equal to 100 divided by 10. So we divide both sides by 10, which means that our optimal quantity demanded for good x is 10 units. Right. So given Rory's income and the prices of these goods, to optimize her utility, Rory is going to demand 10 units of good x. And once we have that, we can find this for good y. We know that Q of y is equal to 5. Right, we plug that in. 5 over 2 times Q of 5 over 2 times Q of x. So 5 over 2 times Q of x. Again, this is going to be the optimality because we need to know Rory's choice when she's maximizing her happiness. So this is 5 over 2 times 10, which gives us 25. Yep. So 25 units. Right? So remember earlier, let's write this again. Green. So optimal quantity demanded of good x by Rory is 10 units, and of good y is 25 units. Now, instead of going through the long process that we just did, if we have our okay, I'll just scroll up. If we have our here demand function, right? For any I and any price, we can use this as opposed to going through all of those steps that we just did. We can just plug in those numbers, right? Not only is that more convenient, it's also a good way to check our work. So here, using demand, the demand equations from we derived in the previous video. We have that Q of x, the demand function here, is I over 2px. So we want to check if this is true. So we know that Rory's income there was 100, 2 times the price of good x is 5. So this is 100 divided by 10, which is also 10 units. Aha, check, that's good. Right, check there. And so much faster, right? And then Q of y is equal to I over 2py. And this is equal to 100 divided by 2 times 2, 100 divided by 4, which is 25 units. Again, check, given what we found earlier. The reason we need this equation, and given the ease at which we can find these units, is that we can use this, oh, my computer's glitching. We can use this to draw the demand functions, which is going to be in the next video. Yay! All right. Again, if you have any questions, let me know. This was us using an example to explain that demand function that we just